There are places in the universe where light has never touched, and now we can see them. When the James Webb Space Telescope opened its golden mirrors to the void, it was not just looking outward, it was reaching back, through time, through silence, through everything that has ever died. We launched it to see the beginning. We did not expect what stared back. It sits beyond the reach of rescue, cold, watching. The first image arrived quietly, thousands of galaxies tangled across space. Beautiful, impossible, but wrong. Gravity doesn't do that, not like this. Patterns where there should be chaos, symmetry where there should be nothing but random scattering. The deeper we looked, the more the silence cracked. Signals, ancient and weak, began to echo in the data. Not radio, not light, something else. A pulse, low, repeating, like breath. We thought it was feedback, but it came from outside, always the same interval, always the same direction, toward a blank space, a region empty of stars, cold, silent, yet pulling. Webb turned its mirrors there, adjusted, focused. What it saw wasn't blackness, it was a mouth, it wasn't metaphor. The universe had structure, the dark had edges, something immense, older than time, had shape. We ran it through every filter. It's not a glitch. There's an eye. I don't know how else to say it, it's looking at us. What does it mean to be watched by something that does not live, something that remembers the dark before the stars? We went to the origin of light and found fingerprints beneath it, as if something had been there first. The signal changed. It was no longer a beat, it was a message. We don't know how long it's been speaking, only that we finally built ears big enough to hear it. They stopped public releases, scrubbed the signals, burned parts of the archive. But not fast enough, it's out there now, a truth too big to hide. Children see it fastest. Patterns and noise, faces and static, whispers and sleep. Not everyone understands it, but everyone feels it. Like waking up in a house you don't remember building, and hearing footsteps upstairs. We thought we were alone in the light. We were wrong. Something else grew in the dark. The telescope didn't just show us what was out there, it showed them where to look. It wasn't just watching, it was waiting. Now something looks back through the mirror, closer every hour. It hums, like breath behind a wall. The James Webb Space Telescope continues to send data. Several segments remain unreleased. As of this documentary, 6 observatories have reported anomalous signals. Do not stare into the void, it may stare back. We humans are curious. We look up at the night sky and wonder, what are the stars? How far away are they? Are we alone? For centuries we've built telescopes, our windows to the cosmos. The Hubble Space Telescope showed us wonders, but science always pushes forward. So we built a new eye, the James Webb Space Telescope, Webb for short. Its mission is bold, to witness the birth of stars and galaxies. Webb isn't a replacement for Hubble, but its successor, seeing the universe in a different light, telling an older story. The James Webb Space Telescope is a marvel of engineering by NASA, ESA, and CSA. Now this dream is reality. A new era of astronomy has begun. The adventure is just beginning. The universe is waiting, and Webb is our guide. What will we find? To understand Webb, we must talk about light, especially infrared light. Infrared is heat. Everything warm emits at you, the Earth even a telescope in space. This is central to Webb's design and its nickname, the cold eye. Webb is built to see the faintest, most ancient objects, galaxies and stars from the dawn of time. As the universe expands, their light stretches from visible to infrared, a process called redshift. Webb must be an infrared specialist detecting these faint signals. But if Webb is warm, it glows in infrared, blinding itself to the universe's whispers. Imagine trying to spot a candle miles away while holding a lantern. The lantern's glare overwhelms the candle's faint light. Webb's own heat would drown out the signals it seeks, so Webb must be extraordinarily cold, colder than any freezer, colder than Pluto. This isn't optional, it's essential for its mission. The cold eye needs the deep chill of space, shielded from all warmth. Only then can it achieve the sensitivity to distinguish the universe's first light from its own heat. Its coldness is its superpower, letting it gaze into the infrared and see the universe as it was long ago. Webb's frigid design is what makes its discoveries possible. Without this cold, the telescope would be blind to the cosmos's earliest secrets. The universe's story is written in faint, ancient heat. Webb is built to read it. Every detail of its construction serves this purpose. The cold eye is not just poetic, it's the key to Webb's vision. By staying cold, Webb can see what no other telescope can. The secrets of the early universe are hidden in the coldest light. Webb is ready to find them. The universe's first light is within reach. All because Webb is cold enough to see it. The launch of the James Webb Space Telescope was a historic moment. Christmas Day, 2021. An Ariane 5 rocket carried it skyward from French Guiana, the hopes of thousands riding on that column of fire. The launch was flawless, but Webb's journey was just beginning. Unlike Hubble, Webb wasn't headed for Earth orbit, but a special spot a million miles away, the second Lagrange point, or L2. L2 is a gravitational sweet spot, where the pull of the Sun and Earth balance perfectly. Here, Webb can orbit the Sun in sync with Earth, always keeping the Sun, Earth, and Moon behind it. This is ideal for a cold telescope, minimizing heat and maximizing darkness. The journey took about 30 days, a month of careful travel and anticipation. During this time, Webb had to unfold itself piece by piece. It launched folded up like cosmic origami to fit inside the rocket. Its mirrors, sun shield, and dozens of mechanisms had to deploy flawlessly, hundreds of steps all in the harsh environment of space. It was an engineering ballet performed millions of miles away. Each deployment was critical. Any failure could end the mission. The sun shield unfurled, the mirrors locked into place, and Webb prepared for its long vigil. L2's unique position allows Webb to stay cold and focused, shielded from the sun's heat. This location is what makes Webb's mission possible. The cold eye needed a home far from Earth's warmth. Now, at L2, Webb is perfectly positioned to peer into the universe's past. The journey was risky, but the reward is immense. Webb's voyage to L2 marks the beginning of its exploration. The telescope is now ready to reveal the cosmos's deepest secrets. Every step of the journey was a triumph of engineering and teamwork. Webb's place in space is as remarkable as its mission. The cold eye is in position, the universe awaits, let the discoveries begin. The heart of any telescope is its mirror. The bigger it is, the more light it gathers and the fainter the objects it can see. Webb's primary mirror is a giant 6.5 meters across, dwarfing Hubble's. This size is essential for seeing the universe's earliest, faintest light. The mirror isn't a single piece, but 18 hexagonal segments like a beehive. This design lets it fold for launch and unfold in space. The segments are made of beryllium, strong, lightweight, and stable in extreme cold. Each segment is coated with a microscopically thin layer of gold, perfect for reflecting infrared light. That's why Webb's mirror shines with a golden hue. All the gold on the mirror weighs less than 2 ounces, but it's vital for Webb's vision. After deployment, the segments were aligned with nanometer precision, an engineering marvel. Tiny motors adjusted each segment until they acted as one perfect mirror. This process took months, but the result is stunning clarity. Webb's optics are a testament to human ingenuity. The golden eye is now ready to explore the cosmos. Every detail from the hexagonal design to the gold coating serves a single purpose: to capture the faintest light from the farthest reaches of space. The mirror's precision allows Webb to see what no other telescope can. It's not just a mirror, it's a time machine. With this remarkable optic, Webb can peer billions of years into the past. The universe's secrets are reflected in its golden surface. Webb's mirror is our window to the beginning of everything. The alignment was a delicate dance, but now the view is clear. The cold eye is focused. The cosmos is about to reveal its secrets. Webb's optics are ready. Let the exploration begin. Webb needs to be cold, but space isn't uniformly cold. The sun, Earth, and Moon all radiate heat. To protect its sensitive instruments, Webb uses a sun shield, a high-tech parasol the size of a tennis court. The sun shield has 5 layers, each made of ultra-thin captain, coated with aluminum and silicon. These layers are separated by vacuum gaps, a clever design that blocks and radiates away heat. Sunlight hits the first layer, most is reflected, and each subsequent layer blocks more heat. By the time heat reaches the final layer, Webb's telescope side is frigid, about -233 degrees Celsius. This sun shield is absolutely crucial. Without it, Webb would be blinded by its own warmth. Its deployment was one of the mission's most critical moments. Failure was not an option. The sun shield creates a permanent shadow, allowing Webb to achieve the cold temperatures needed for infrared observation. It's one of Webb's most complex components, a marvel of engineering. The 5-layer design ensures the telescope stays cold, even with the sun blazing nearby. The sun shield's success is what makes Webb's mission possible. It's not just an umbrella, it's a lifeline for the cold eye. The telescope's vision depends on this shield. With the sun shield in place, Webb can see the faintest signals from the edge of time. The universe's secrets are hidden in the coldest shadows. Webb's sun shield keeps those shadows deep and dark. The cold eye is protected. The cosmos is ready to be explored. Webb's high-tech parasol is deployed. The search for cosmic origins continues. Our eyes see only a sliver of the light spectrum, visible light, but the universe is filled with other kinds of light, especially infrared. Webb is designed to see in infrared, detecting invisible light our eyes can't. Why infrared? First, the early universe. As galaxies move away, their light stretches into infrared. Webb captures this ancient, red-shifted light, letting us look back in time. Second, star and planet formation. Infrared light penetrates dusty clouds where stars and planets are born. Webb's infrared vision reveals these hidden nurseries. Its cameras and spectrographs are incredibly sensitive, able to detect the heat of a bumblebee on the moon. This sensitivity, combined with its cold temperature and large mirror, makes Webb a powerful explorer of the hidden universe. With infrared eyes, Webb unveils cosmic secrets once shrouded from view. The cold eye sees what was once invisible. After years of anticipation, Webb's first images arrived in July 2022, and they were breathtaking. The deep field image revealed thousands of galaxies, some over 13 billion years old. Gravitational lensing created cosmic arcs and mirages, showing the universe's depth and history. Other images like Stephan's Quintet and the Carina Nebula unveiled star formation and cosmic landscapes in stunning detail. These weren't just beautiful, they were packed with scientific data, challenging our theories. Webb found galaxies in the early universe more mature than expected, forcing us to rethink how galaxies form. The cold eye is already rewriting our understanding of the cosmos. Webb's discoveries have only just begun. Are we alone? Webb is helping us find out by studying exoplanets, planets orbiting other stars. Using the transit method, Webb analyzes starlight filtered through exoplanet atmospheres, searching for key molecules like water vapor and methane. It's already detected these gases on giant exoplanets and is pushing to study smaller rocky worlds in habitable zones. Each observation brings us closer to understanding our place among the stars. The James Webb Space Telescope is more than an instrument. It's a time machine and a portal to the unknown. Every image is a discovery, every dataset a potential breakthrough. Webb challenges old theories, inspires new ideas, and propels science forward. The universe is grander than we imagined, and Webb is just beginning its mission. It will operate for years, unveiling more cosmic secrets. The cold eye brings back light from the darkness. With Webb, humanity continues its bold exploration. The adventure continues.